Okay, I took too long on these ones, and now I'm better with this. So the basics of MO diagrams are there are two types of bonds, the sigma bonds versus the pi bonds. So sigma bonds are going to deal with s orbitals, and they're going to mainly be hydrogen because they only have that one singular bond, and these s orbitals, little circles, versus the pi bonds, which look like these, and deal with sp(x) molecules. So you're always going to see them in a molecule like this. So you'll get something like this rather than something like this. Anyways, in it, we deal with energy. And right here, these little lines represent the number of MOs. And each line has a specific set of nodes. So 0 nodes will be on the first one node, second, so on and so forth. The number of MOs will always equal the number of sigma bonds or pi bonds. So if you see here, we have H5 plus. H5 means there's going to be 5 little bonds, so 5 sigma bonds. Therefore, there will always be 5 MOs, no matter what. Electrons correlate with protons, but we have to take this into account as well. So 5 means 5 electrons, but with this means 1 is away. So there are technically 4 electrons. So we're going to stop here to understand what this means. Here we have a little graph to kind of understand how this works. So we have to think of it in terms of wave functions. With 0 nodes, it's going to be symmetrical, and it'll only have something like this. 0 nodes, because nodes happen when you cross this line. So it's symmetrical because when you split down the middle, it looks like a mirror. If you put your hand on this side, it'll look the same right here. Therefore, it's symmetrical. Here, there's only one node because it passes once, so the node is there. It's asymmetrical because when you split it down the middle, there's one up here, one down here, rather than it being a mirror side by side. And then for a big tip, everything above is positive, everything at the bottom is negative. That's why you see this. And as it alternates, you'll see positive, negative, positive, symmetrical when split down the middle. And it has 2 nodes, 1, 2. And then same thing here, 1, 2, 3 nodes. 2 positive, 2 negative. But it's asymmetrical, again, because if you put it against a mirror, it doesn't look alike. Therefore, it's asymmetrical. And that's basically what this means. So when we build this and work on this problem, we're going to have something like this. Energy, this little dotted line. And this dotted line means they're the atomic orbital lines. But that doesn't matter in understanding how this stuff works. So with 5 MOs, we draw one here in the middle because it's odd. And we're going to keep these two symmetrical. So 1, 2, 1, 2, and 5. These help to understand electrons. So let's fill this out now. When there are 4 electrons, that means these two are filled up all the way. The reason this is important is in terms of labeling this. We have this thing called LUMO and HOMO. LUMO basically means the lowest energy with an empty orbital. So this right here would be LUMO. HOMO is the opposite. It's highest energy, but of a filled one. So you have HOMO. And if you have one, you'll always have the other because LUMO is always above the HOMO. And then now the understanding it, how these build up. So the way this works is 2 ways. You can either draw them like this. So since there are 5 sigma bonds, we draw the 5 bonds. Or you can draw the charges by itself. I like doing this because it creates a base of how these things work. So 1, 2, 3, 4, 5. All the way for each MO. Perfect. So in respect with this, we have to remember at the bottom, there are going to be 0 nodes. This one will be 1, 2, 3, and 4, just like in this one. And then same thing, if this is symmetrical, this pattern will always follow, no matter what. And the way we learn of how this works basically is, if you remember the wave function, this is positive. So that means these will all be positive. So you can either do this or shade them all in. It really is up to you. I like to shade because it helps me understand. And now let's take into account the nodes before we even do the shading, learning whether it's positive or negative. So when we have a node, it basically means you want to split these into the groups, an even group. So if there's one node, we can't put it here because that's 2 and 3. We can't put it here because that's 3 and 2. Can't put it here, 1, 4, so on and so forth. So this middle one actually becomes the node. Okay. Now when we go to the second one, this one will have 2 nodes. And we can't, again, it's hard, but we do the same thing. This one becomes a node, and this one becomes a node, getting rid of them effectively. Or the way we see it in charges is, so when we have this one, this will follow this pattern. Positive, and then negative, no matter what. And here, it'll be positive, a long string of negative, and then positive. Or shaded, unshaded, shaded. These will be shaded, shaded, empty. Now for 3 nodes. It's hard to do with an odd one, but keeping it straight down the middle follows this, but now we need 2 more nodes, which is easy because we can split this and split this, and we can follow the pattern again. So with 3 nodes, it's going to be positive, negative, positive, negative. So we're going to have positive, negative, so empty, positive, negative, so empty. And now the last one, this will have 4 nodes, and it's easy because they all have a space in between. So 1, 2, 3, 4 nodes. So then this one will be the same. So it's going to be 4 nodes, means draw that line. 1, 2, 3, 4. 3 positives, 2 negatives, and they alternate. So 1, empty, 2, empty, 3, and they match. So that's how you do that for sigma bonds. Going here, it's a bit more complicated because of the pi bonds, but basically here we look at it like this: 1 pi bond here, 1 pi bond here, 1 pi bond here. And the way we have to remind ourselves is that it's basically like resonance. That's why the electrons are going to be passing. On double bonds, there's going to be 2 electrons, and on here, a single lone pair will be 2 more. So that means 4 electrons here. Here, pi bonds, 1, 2, 3, MOs will match. So going here, energy, dotted line, middle, 1 and 2. Here, 1 is filled, 2 is filled. And unlike here, where they're at the bottom, that means HOMO is going to be here, LUMO will be here. And that's okay, because that's the rules regardless. But in terms of shading, it kind of gets harder for p orbitals, but it'll work the same regardless. So here we have 3. The top ones will be shaded, not the entire thing, just the top ones. And then here, 1, 2, 3, with 1 node splitting it, shaded, unshaded, following this pattern, shaded, unshaded, because positive, negative right here. And last one, 1, 2, 3, with 2 nodes, 1, 2, right? It's going to be 2 nodes, positive, negative, positive. So positive, empty, positive. And that's pretty much the basics of ML.